as we start chapter 2, we're going to get into different types of relations and functions. We have used the vocabulary of a function before when we talked about function notation with evaluating expressions. We're going to continue to talk about function notation, not just for evaluating, but for also looking at a graph. And so our objectives are to analyze relations and functions, to interpret relations and functions in terms of their domain and range, and we'll talk about what domain and range are, and to evaluate using function notation, whether that be with an expression or on a graph. And so our first idea here is that we want to talk about that a relation is a set of ordered pairs. Essentially, anything that you could graph on a number line, or on a coordinate grid, is a relation. So it's a set of ordered pairs. It could be a lot of them. It could be continuous in the sense that it's a line or some kind of shape on the graph. It could be just distinct points on the graph. Both of those would be examples of relations. The domain is the possible inputs into a function. The domain is what you're allowed to plug into a function. And so, for example, when you talk about things, the values that I'm allowed to plug into this function, there are times when you're not allowed to plug certain numbers into a function. For example, if I had f at x equals the square root of x, we know that we can't plug a negative number into a square root. And so that would give us an error on our calculator if we took the square root of perhaps -4. And so that would mean that values that are negative are not in our domain. Other situations that come up a lot is that you're not allowed to have 0 in the denominator. So if I had the function 1 over x, my domain would be any real number that didn't include 0, because I can put negative numbers in, I can put decimals in, I can put positive numbers in, but I cannot put +0 in here, and again I would get an error in my calculator if I tried to do that. Domain goes by other names. For our purposes, a lot of times it's going to be x, the value that we plug into a function. So here we would plug in x. It's also the inputs here. What are we allowed to plug in to the function? The range is the possible outputs. What can we possibly get out of this function? So again, if we look here, it's not possible to get a negative answer. Since I can't put a negative number in, I can't get a negative answer out of this problem. Whatever I take the square root of is going to be a positive value. And so what could I possibly get out of this function? What could be the possible results? And so in this function, there are no negative answers. In this case, I can plug in anything I want other than 0, but it's not possible to get out anything that's equal to 0. There's nothing I can plug in here to get 0 to come out. Other names that we use for range are y. The y values are essentially your range. Sometimes we use the f of x, and like it says here, this could also be output. The functions that we're going to talk about and what you're used to working with are types of relations. They are a set of ordered pairs, but each input has exactly one output. And this may seem silly to say, but there are situations where a relation is not a function, where I could plug something in and there's actually 2 possible answers. Here, as long as I plug in one value, there should only be one possible output. So for every domain value, there should be only one range value. So let's take a look at example number 1 here. It says state the domain and range of the function, then determine whether the relation is a function. So the domain, if we remember from up here, is our x values. So what values did we plug in for x? I'm going to read them from left to right for each point, and we kind of use this notation. The D is for domain, colon, and then that squiggly bracket. And then my values are -4, -3, 0, 1, and 3. If a value happens more than once, I would still only record it in the domain or the range one time. Then if I go down here to the range, my possible outputs, things that I could get out if I go from the bottom up. The -2 happens twice here from the bottom up, but I'm only going to record it once. And then I've got 1, 2, and 3. 1, 2, and 3. So one of the things that can help you decide if something is a function or not is this box down here, this vertical line test. If I can draw a vertical line through more than one point, then it is not a function. So this is a function because anywhere I draw that vertical dotted line, I'm only going through one point at a time. This example is not a function because I can draw this dotted line and it hits 2 points, which is not allowed to happen. So one thing I would do is kind of draw that dotted line through each point and see, do I hit more than one point at a time? And as long as my line is vertical, I don't hit more than one line at a time, so this is a function. For example number 2, again with the domain, I'm going to look from left to right. I've got -3, 0, and again I'm looking at the x coordinate of each point, 2, and 3. So -3, 0, 2, and 3. My range or my output are my y values, and so from the bottom up I've got -2, then -1, 0, and 1. And again, if I do my little vertical line test, and I hit 1 here, 1 here, 1 here, 1 here. So this is a function. So things to remember from this first page is that your domain are essentially your x values. So when I was looking for domain, I was looking at the x coordinate for each one. The y coordinate is my range. Even though the -2 happened twice here, it only occurred once in my range. So let's flip to page number 2, please. Page number 2 is going to give us a little bit of additional information. The table below, for example number 3, shows the average fuel efficiency in miles per gallon for SUVs for several years. Determine whether this is a function, and then we'll talk about this continuous or discrete. And so to determine if it's a function, I'll use my vertical line test again. So I'll cut here, 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 and here. And at no point did I hit more than one point, so this is a function. And this is what we call discrete. I say discrete because it's individual points, not a line that's connecting them. For example number 4, again, I'm going to check and see if my vertical line test is going to hold. And again, as I look through each of these, I don't hit the same point twice, so again, it's a function. And then this is also a discrete function. It didn't ask me that, but I can record it anyway, because each of them are individual points. It's not a continuous line. So then, as you get into working with problems like example number 5, it gets a little bit more complicated, and this is a time that it's really helpful to go to your calculator. So on your calculator, you're going to go to the graphing function. So I'm going to get out of here real quick. You're going to hit y equals right here, and you're going to type in this equation. The y1 is the y, so I'm going to type 6, and then you need to hit the x button that's right here. So this one right under mode is the x I'm going to use, and then I'm going to hit the graph button. And this is going to graph this for me. Now you only see a very small portion of the graph. We know that this line continues on forever up this direction and this direction. So what I'm going to ask myself is, what x values do I eventually hit? Well, in this case, the x values will continue forever this direction. You can't see them all in my graph, but I know that it continues, and continue forever in this direction. So my domain is what we call all real numbers. You could also just write all real numbers. The range is the y value. So as I look from up and down, again, I know it keeps going up, I know it keeps going down. So my range is also all real numbers, or you could write it as all real. Right? Well, that seems pretty straightforward, but let's take a look at the next one. So go back to y equals, clear out your last answer, and now I'm going to hit x squared is my next function. I'm going to graph that. So now we have a parabola. This line again continues on forever up to the top and continues going this direction, continues on forever this direction, but I have nothing in the bottom part of my graph. So for the x's, I would eventually get to all of these things, and I would eventually get to all these things. It's just not on my graph. So my domain is still all real numbers. My range, however, starts kind of here at 0 and only goes up. There are no values down here underneath the y-axis, and there never will be. And so my range is y has to be greater than or equal to 0. So any y value I use has to be greater than or equal to 0. We kind of talked about these examples before. For example, we said that we can plug anything we want to in here for x except 0. My range is going to be all values except 0. We can't get 0 out. We talked about that one as well. If you wanted to graph that, you certainly could. Y equals 1 divided by x. But when you graph it, you're not going to notice that right away. What these are is that they're kind of getting close to the axis, but they're never actually reaching it. So at no point does this cross the x-axis, or the y-axis for that matter. Then we've got the square root function. So y equals second, and then I use this x squared to get the square root of x, and then I close my parentheses and graph it. And I notice that this graph is only in the first quadrant. It starts here at 0, 0, and goes up and to the right, but it's never in the negative x's, so my domain has to be x is greater than or equal to 0, and my y's are always positive as well. They're always greater than or equal to 0. We will talk more about domain and range from functions a little bit later. What we have done before is things like examples 6 and 8. So for example, for something like number 6, what they're saying is to plug in -2 everywhere we see x. So f at -2 equals -2 to the third power minus 3. This is just my solution. I don't have to do anything to solve this. This comes down as part of my problem. F at -2 equals -2 times -2 is positive 4, and positive 4 times -2 is -8 minus 3. You're welcome to do that in your calculator. And then overall f at -2 equals -11. So what if we had that same problem, but now we're plugging in something that's not just a number? So now we're doing f at 2t. So now I'm going to put 2t in for x and cube it and subtract 3. Now we're not evaluating to get a single number as our answer. We're evaluating an algebraic expression. So f at 2t is going to be 2 times 2 times 2 is 8. T times t times t is t to the third minus 3. But at this point, there is no other work that I can do to simplify that problem. On your own, I want you to try examples 8 and 9.